Good afternoon to all the global participants of the actually second webinar of the International Magnesium Association, titled Magnesium in Aerospace and Defense Application. And here with me, Andrew Spears and our America's representative, Rose Eaton, and my name is Martin Tauber. We are welcoming you to this webinar. Before I take the liberty here to also to make introduction to the International Magnesium Association, the IMA, how we call us in short, we consider us as the global voice of the magnesium industry, mainly to provide value for its members and information for the stakeholders, and in promoting the magnesium metal in various applications. Representing the memberships on a global base, making environment, health, and safety as the main issues in our committees as well, and providing our members and stakeholders with information in accurate and hopefully also in timely manner, and also trying to provide for our members that we can achieve more as a group, as an individual member can. So in a nutshell, I think we have under our participants a lot of members, but we are, of course, welcoming all our non-members as well, and probably also you are interested in joining our global network. There's a little bit of change of the presenters. We have three presentations today. We have Nils Backeberg from Project Blue. We have Ross Baird from Luxfer MEL Technologies, and also Ms. Navin Kumar from Hindustan Aeronautics. We had actually planned a fourth presentation, but if you allow, I will take the liberty to give you a short intro about the magnesium metal as a strategic or critical material in the impact of defense industry, also in the view of the defense industry, which is kind of a raw material perspective for the webinar, because I think especially the third and the second presentation will be application focused. Before we start, some information and housekeeping. The webinar is recorded. You will get, as participants, you will get the presentations, and you will get the recording. And also the recording will be available to our other stakeholders as a third party, also for non-members via the IMA YouTube channel. You as participant, you can ask questions about the Q&A function, so the presenters can actually answer the questions through the chat, or answer the session after the session if time allows that. If some questions remain unanswered, we are trying to get in contact with you per mail on that. Again, we are thanking the speakers and thanking the IMA staff to support the webinar, and we received actually, I think the latest number was 149 registrants for this webinar. I will just introduce this topic here. I have to click out the yes. So magnesium as magnesium metal is recognized as either strategic or as critical in most of the regional and national and global lists. Most of you know that. Defense plays a very heavy weighted role in that. But however, the defense sector is mostly issuing their own lists, which are different to the so-called commercial list as well. For aerospace in general, we had a lot of applications also in commercial aircrafts before, but it was largely discontinued because of corrosion concerns, but is now gradually reemerging into the market. Magnesium in general plays a heavy role in defense applications. Is it munition? Is it air, sea, or land transport or equipment? And because of the current geopolitical developments, I would call that defense projects funding, especially for companies who are producing defense products, is increasing a lot. Also, strangely enough, that then NATO has published a list of 12 critical minerals, which are not including magnesium metal, but I will come in a minute to that. I can't go to the next slide. Why is that? Okay. Here's some examples. This is from the European Defense Agency report, I think from 2023, in coordination with also the other European policy initiatives like the Critical Raw Materials Act. As you see with these application examples there, it's very hard to see, but I can assure you that magnesium is on all the slides here. And if we talk about magnesium for defense and as aluminium alloys are also very heavily used, is actually the magnesium and the aluminium alloys perspective interesting for us. Some other examples here from an independent company who combines all the different lists and selected also a couple of raw materials here. And you see in the defense and related application that magnesium here plays a medium role. But interesting in that on the right side, possible also hard to see, is that magnesium, and when you look down at the end, under C's defense and other applications, that magnesium is actually listed in most of the defense applications there. So this confirms very heavily used. An example from the US, I think recent published lists, there are two sides of the lists, one from critical materials for energy and one for critical minerals. And for instance, you see very prominent, the first statement, because of the criticalities, defense and aerospace applications are named. And on the bottom, you see the different materials in criticality assessment. And you see at the short term, which is now ending this year, magnesium is on a mid yellow dotted, and which also goes into a medium term, the next 10 years, that magnesium is listed as a red dotted critical material. The last one I show is on the NATO list. The NATO list was published last year, and is actually based on studies from the Den Haag Institute, lists 12 materials which are critical to military applications. Strangely enough, magnesium is not under these 12 materials, but it's also not under the list of considered materials, which you have on the right side. So this was very strange to see that. And I don't know why, but we have asked about that. We have commented that list on social media as well without any response. So far, we'll continue doing that. We see manganese on that list, and what we have seen in the past as consultants and policymakers are still mixing up manganese, magnesium, and magnesite in these critical raw materials assessments. So with that, just want to, as a closing there, I want to demonstrate that if we are on the list or not, what a difference does it make? I think the IMA opinions is that we have to encourage our material to be on such lists. This is just an overview what impact it could have on the market. And NATO has here, the bloc has identified 6 areas. First is identify key vulnerabilities, to prevent supply disruption risks and declare the material as strategic. Second, strengthen supply chain resilience. Measures including here strategic stockpiling, recycling, substitution. I think interesting for an industry, especially stockpiling. Third, ensure operational readiness and technological edge to overcome shortages and to be that's the impact on the readiness of the block. Fourth, policy cooperation amongst allies. Cooperation will span procurement, stockpiling, again, risk assessment, possible trade policy. Fifth, public transparency and signaling. That is also a mirror that it will encourage, attract investment into our industry, and guiding research, innovation, and substitution as the last one, like R&D alternatives, not also into substitution, but also into, for instance, recycling technology. So with that, I think it's very important to be on such lists, and IMA and its members will encourage and will inform policymakers for this as when there are new assessments coming up. So with this input from the policy area, I will hand over to our first speaker, Dr. Nils Backeberg, founder and director of Project Blue. Nils worked before also at companies like Roskill and Wood Mackenzie. He has an academic background, actually, for 3 different continents, so South Africa, Canada, and the UK. And he will talk about trends and forecasts in aerospace defense application, in particular magnesium. And when I met him again in Lisbon this year at an MMTA conference, I knew that he is the right person to kick off this webinar. I will stop sharing. I'll give you the screen.
Yeah, okay. It's allowing me to share now. Hello, good morning, good afternoon, good evening, everyone. Thank you, Martin, and thank you to the organization for hosting us here today. I'm going to talk about trends and forecasts in aerospace and defense applications. We've put together some quite exciting research, putting together superalloy analysis, and so I'm very excited to share this with you today. This will be only the second group outside of ourselves that gets to look at some of the results, and I'm very keen to get feedback from everyone and see where this discussion goes. As Mark mentioned, my name is Nils Backeberg. I'm one of the directors at Project Blue. Just to give you a quick introduction to who we are, we provide independent market intelligence across critical material supply chains. We've got a nice global footprint. I'm calling you from Stellenbosch today, but headquartered in London, UK, and a team across the world that supports our research. We work through subscriptions and consulting across, we try to cover the periodic table, and we're doing pretty well at that. And as part of that, what we get to do and where we leverage our expertise is identifying cross-cutting themes within the different commodities and nuances as well. We're talking about lithium-ion batteries, all the nuances of the commodities and superalloys in general. And because we cover things like titanium and rhenium, where aerospace makes up the large majority of demand, this is sort of ventured our way into building detailed aerospace analysis. So just to let you know, all of our research is underpinned by our own independent research in the different sectors. We have our views, what underpins the demand drivers, and the supply and demand analysis, price analysis, trade analysis that sits behind each of these commodities. I won't go into the detail of the magnesium research. My colleagues will be presenting that at the next conference for the association. So hopefully you can get some more information on that. I'm really going to be focusing in on our aerospace research. There are forward-looking statements, so the usual disclaimer in terms of your due diligence, and but I hope you enjoy the narratives that we put together. This is what we do. So to give you a sense of what we've built, and jumping straight in, we've been tracking aircraft deliveries and orders for various commodities. And what we've done then is by forecasting out the landscape, specifically post the COVID pandemic and the unfortunate fatal crashes from the Boeing Maxes in 2018, where you saw significant impact to aircraft deliveries, and the demand for these raw materials were impacted in that. Trying to understand, when is the aerospace industry recovering? We saw a fast recovery post-COVID, and I'll show you some of the data. But there have been a few things in the pipeline that have impacted the market. Disruptions to other supply chains, ongoing issues with certifications, and also the entrance of COMAC out of China. And with regards to various supply chains, there's key nuances to dive into. Now, what we've done in the process, on the bottom side of this slide you're looking at, we've taken over 450 aircraft models and split them out into their different parts and assigned superalloy formulations to the different parts and applications across these aircraft. We've done the same for engine parts for over 110 engines, and broken down the parts into the details, and again, we've got all the superalloy analysis in there to cover that. And what's quite interesting from the superalloy perspective, if you're focusing in on that, is the aerospace industry itself accounts for around 50% of the superalloy market. We're busy finishing off industrial gas turbine research, which will give us the next 25% of that market. So we're doing some really niche and nuanced research to understand the superalloys industry, which has been a lot of fun. So I hope you enjoy what we've put together. So this is some of effectively the output at the end. This is a snapshot of a Power BI dashboard. I do have it open live over here, where you can see, we can start to identify, if we look at Boeing, what alloys are they using, Airbus, what alloys are they using, and even Embraer, and try to understand what commodities go into the different parts of the aircraft. So it's a live dashboard, so just showing you a snapshot here. And you can see the aluminium alloys. This is looking at frames. Sorry, I can't see the top of my screen, but that's fine. Ah, there we go. Now it's moved away. So this is looking at aircraft frames. You can see aluminium alloy is exceptionally important. This is really where you see titanium alloys in here, magnesium alloys sitting in here as well. Here they are in the small blue at the top. This is in terms of total volumes of the aircraft weight. Doing the same for engines looks slightly different. Lots more centered around nickel-based alloys and special alloys going into the engine and to the different parts. And again, breaking this down by, Rolls-Royce, Pratt & Whitney, etc., all the key OEMs. And you can see how commercial is really the definition or the definer of the overall pattern for demand in the aerospace industry. But military for engines makes up a significant portion. Going back one slide, slightly less on the frame side, and that's just the relative proportion of materials used for the frame versus engine when it comes to a fighter jet. But on the right-hand side, you can see aluminium, sort of high volume material, iron, titanium, magnesium is sort of the fourth largest element used in the alloys in an aircraft frame. So a very, very important metal when it comes to the aerospace industry. For engines, it falls slightly lower, but still in the top 10 of commodities used by volume in engines. So what we've been able to do in this process, on the left-hand side, again, looking at airframes, on the right-hand side, so looking at the intensity of use of magnesium per weight unit of an aircraft. So on the left-hand side here, looking at narrow bodies and wide bodies. And in the middle here, you've got fighter jets and bombers. And so you've got the intensity of use low for certain applications. And you can see that here, Boeing, Airbus, relatively high. COMAC, with this is the Chinese aerospace manufacturer, or the aircraft manufacturer, having a relatively low intensity of use in there. Now, this doesn't really have a huge impact on the magnesium demand at the market. COMAC, a relatively small production pipeline, although orders are quite high, but gives you a good sense to how things vary across that. And the same for use in engines, obviously much smaller numbers, and 0.1% versus 1 to 2% intensity of use in a frame versus an engine. I'll come back to that. And so we can break this down a little bit further. I mentioned to you the sort of disruptions to the aerospace industry post-2018 and into the COVID-19 pandemic year in 2020. Quite a rapid recovery, 2022 and 23, with everyone eager to step back outside and travel. But yeah, we've seen really this disruption to supply chains of the last 2 years, with the aerospace industry struggling to recover to its delivery rates prior to the COVID pandemic. So ongoing issues in there. And you can see here where we are breaking this down by the different OEMs, so Airbus and Boeing at the bottom here, other commercial. This is really where we do see some penetration from COMAC ramping up. Military in yellow here, private planes also significant, and then helicopters also playing a good role in that. So what are the parts in the airframes that sit behind? Yes, it's the fuselage and the main body, wings and control surfaces. And just for this is in kilotons magnesium element or metal, right? Just to note, this is cumulative data from 2015 to 2035. So there's a few nuances sitting in here in terms of developments in the alloys and so on, and how that is looked. But you can see here, the most prominent use and demand is magnesium used within an aluminium alloy. You can see aluminium lithium alloys coming through here, aluminium scandium also used, and then magnesium alloys as well. So what we can do with this data as well is try and pull out these nuances that I keep referencing, right? And for every commodity that we then now look at this, there's going to be a different story. I mentioned we've done this for tantalum and niobium on a previous conversation I had with the organizers, and trying to find different nuances in there. Titanium, we're showing you over here, so a high use of titanium in military as a intensity of use in aircrafts. And really magnesium sitting in here. What this is really showing to you is that actually you have titanium, vanadium, aluminium alloys replacing other aluminium alloys in certain applications, specifically high performance. So what this doesn't indicate necessarily low demand, it's just for the units consumption in here. And again, what we then also get to pull apart, this is average narrow body, average wide body across all of the data that we have. But if you then break it up between sort of a third generation aircraft versus fourth generation aircraft, you can start to see changes and evolutions in the alloying materials, right? So aluminium alloys dominate magnesium usage in aerospace. These are frames containing magnesium throughout the entire aircraft, right? Fuselage, wings, empennage, landing gear, control surfaces, etc. And then aluminium lithium alloys, they're used more selectively but concentrated in the main body of the aircraft. Aluminium scandium alloys remain rarely applied, but where used, they reinforce the supporting structures. And I'm sure that we'll hear more about that from our other speakers coming up. And then, magnesium alloys historically applied more broadly in airframes, notably in avionics and cockpits, control surfaces, doors, tail sections, etc. The use has declined sharply due to flammability and corrosion risks. But again, what you can see here, even though there's been a change in the alloy makeup, the demand for Gen 3 over the whole period, it's, what's this, 5 million tons, if I've got the number there right, it's increased here to 8, right? So it's not causing necessarily a decline in demand overall, but there is a change in the intensity of use. And we can see this demand running forward. And I'll show you what the forecast demands look like. And in military applications, we see a very similar breakdown, but electronics, avionics systems really using more of the magnesium alloys, but slightly different breakdowns compared to commercial applications. And this will have to do with the performance of the alloys necessary to operate at higher temperatures and pressures in one application versus the other. So we're trying to pull out the key narratives for all of the commodities through here. For jet engines, same story, just different data sets. So much smaller volumes in engines, but gearboxes, accessories, really sort of the standout parts for jet engines that use magnesium in its various alloys. And you can see here the different OEMs. So this is, you get to know now who you should be knocking on your door, or who you should knock on, whose doors you should knock on, is what I meant to say, with regards to who you should be talking to about the criticality of magnesium for their supply chain. How exposed are the different OEMs to the use of magnesium in their alloys, in their products? And I think that's a good point for me to just quickly comment on something you said earlier, Martin, is that why are these commodities not necessarily finding their way through to criticality lists? And in many cases, depending on who you talk to down the value chain, we're finding that when you talk to some of the end consumers who purchase the alloys, they are unfamiliar with where that material is coming from, or even what elements are inside their products. right? We had certain people mention to us in Europe that gallium is not critical to their value chain because they purchase their products all in Europe. But the traders in the room who sell to them indicated, just FYI, we buy all of our gallium from China, so it should be critical. So it really is a perspective thing. And so the education of understanding the supply chain is exceptionally important to understand all of this. So what can we do with the data? So that's sort of the breakdown of magnesium use in aircrafts and engines. So just to show you, where do we see this market going? So Boeing and Airbus, this duopoly that's evolved over the last 2 decades in here. And obviously now we're still coming out of the disruptions from the COVID-19 pandemic and supply chain concerns around various parts of the aerospace industry. So we see a steady recovery in there. And we only expect deliveries to go back to sort of record levels in the late 2020s into the 2030s. But yet at the same time, we're all starting to go back to travel quite normally, and we're back into record levels now already, right? Indicating that maintenance requirements are actually being strained a lot more than new deliveries at this point in time when it comes to the aerospace industry. So the demand from a maintenance perspective is back to where it was and even going on beyond that. And the same comes from the engines delivery outlook in here, so looking at the same data. A key thing to understand is the sort of steady incremental encroachment here from COMAC, from the Chinese. They've invested heavily in building out the aerospace industry right now. They don't yet have their own engine program. It's in development. There's various conversations about when that's expected to come online. But this will really start to shift supply chains depending on where aerospace grade materials and super alloys are being produced and what that supply chain looks like. Titanium is an interesting one to get into with that, with the Russian-Ukraine conflict, but that's not one to go into on this call. Right, what does it look like for magnesium end-use demand? So you can see a rapid increase in magnesium demand in aerospace here into the 2010s and drop off. Just to note, this is end-use demand. So this is the final magnesium in the aircrafts and in the engines that you see above. It's not the total demand for the raw material, right? There is what's known as a buy-to-fly ratio. There are cutting and shavings to make all of the different parts. 3D printing will play a key role for certain elements more than others. So just to put a disclaimer to this graphic here, this is looking at end-use magnesium demand that's in the aircrafts, in the delivered aircrafts coming onto the market. You can see the relative proportion of engines a lot smaller, and it really is the airframe that's driving the overall demand. On the left-hand side, just talking a little bit about what's the risk to this, what's the scenario outlook for the aerospace industry. Now, the red line, our base case, looks at what Boeing and Airbus are projecting over into the mid-2040s of about 40 to 45,000 unit deliveries. There is a high case scenario in here, right, where we see sort of revenue passenger kilometers. That's this RPK number, which is a measurement of how much we're flying. The upside here is that supply chain disruptions are overcome and aerospace deliveries, can ramp up and actually meet on with demand. Unlikely, I think right now we're weighted a little bit more to the low side, so our base case is significantly below that. There is a low case scenario right now, right? Short haul flights are being replaced with high speed trains, either through legislation or through availability. Disruptions, change in consumer behavior to travel. Electrification. If you go back 10 years and looked at electric vehicle forecasts, the range in high case and low case also would have looked something like this by 2050. But as those technologies have evolved, as we've seen certain things develop, those have started to narrow, and we're starting to understand a lot more what the range of raw material requirements are. For the aerospace, the scenario is mapped out here about green transition and not effectively. There's still quite a wide range in demand for magnesium and demand for any of these raw materials going into the aerospace industry. So lots to still evolve here in terms of technology. A lot of this will depend on various factors, including policy and understanding on supply chains. So just to put this into context and finalize, why is magnesium critical in this aspect when you're looking at the duopoly of Airbus and Boeing? A lot of the magnesium metal exports, production is sitting in China. We'll present more of this at the conference coming up, so I'll just jump through this quite quickly. But really what we're seeing, despite high prices, the imports of materials from China aren't impacted. They are crucial for the development of the different products. But fundamentally, the market is driven by developments in China. You saw the energy crisis in China impacting the global availability and pricing for magnesium. Just looking at the USA and dependency on imports, large efforts on diversification, but still requirements from China and other areas to import this. Domestic feedstock availability is not able to substitute. And you can see the scrap imports ramping up over 2025 already into the USA. And just to finish this, just to marry this together with what Martin was talking, critical materials lists, all are looking at magnesium metal, the availability of it is quite known that China's producing a lot of it. When we look at our supply and demand balance outlook, and again, more to that on another call, we see China's development in capacity staying pretty much ahead of demand. However, that's these sort of blue lined graphic here are projects in China ramping up that we expect to keep pace with demand. There are projects outside of China that can add incremental value or volumes to the market. And a lot of these will be looking at geopolitical supply chains. And what I mean by that is security of supply for certain supply chains to enter the market. And it will be dependent on all of the different applications in the aerospace. On the total volume of things is not the largest application for magnesium, but it is one that is growing significantly, sort of 6% CAGR. And specifically within the geopolitical context, the developments of the duopoly and the arrival of COMAC, there are changes coming in the supply chain that will impact all of these superalloys. Right, Martin, I will end it there and then hand over to questions now or later. I'll let you manage that. Thank you very much.
Thank you, Nils. Probably have some comments about your market figures. Estimate 25 is a little bit too pessimistic for me. Following the second quarter already, it will be a little bit more than showing that, but you will certainly update this. I'm sure. We had a few questions. If you could look at the answer box.
Drone companies. There's a few technical questions in here that I'll leave for the other panelists to address.
Most of them we've got the answers. Yeah,
we've got drone data. We have built our drone demand. I haven't pulled that out of the graphics now. So there's one from Alex Miller. I'll have a look at pulling out some information on drones and see if I can share that with the group. I think a lot of this is going into the technical detail, which I will hopefully leave over to my colleagues here to maybe help me out with, and needs another conversation, including my analysts, to go into the details. So I don't think anything specifically that I can help answer at this point.
Okay, thank you very much. So I think the drone market is certainly something which is emerging now. It is on every, like the future technologies, also for the European Commission. Drone is very prominent as well. I was on a drone event in Germany, so most of the companies there didn't even know what magnesium is. So I think we have to also educate this market a lot.
I think this is a key point, just to take that point again, right? Is people buying the products and understanding what's in those products is really a key gap in people's education to understand what is the risk of supply. And I think there's a huge gap to be answered there.
Okay, Nils, thank you again. I see that a couple of questions are coming in. Maybe you have a look and try to answer them. I think everybody can access those questions then as well. I will give the screen to Ross Baird. Ross Baird is Director of Growth, Magnesium Alloys at Luxfer MEL Technologies. He has been in this role more than a year, but he has been in different roles in MEL or in Luxfer, I have to say. And he's probably the most experienced and qualified person to talk about applications in magnesium applications in aerospace and defense. And also I want to congratulate you and MEL Luxfer for their 90th company anniversary this year. So with that, I give the screen to you. Or you can claim it, I think.
Thank you very much, Martin. Hello, everybody. Thank you for that very kind introduction. I'll just share my screen and then we'll go into the presentation. Is that working? Here we go. Screen 3. And share.
Yes, that's coming.
Great. I was going to say, hopefully Martin will tell me if things come through. Okay, so is that sharing, Martin?
We can see it, yes.
You
Go
can.
ahead.
Fantastic. Thank you.
Thank you.
Thank you very much. So, yes, hello, everybody. I'm Dr. Ross Baird from Luxfer Technologies, and I'm going to be talking to you about some of those, the applications for magnesium alloys in aerospace and defense. Hopefully, I might be able to answer one or two of those questions that have come up throughout the presentation. So just first of all, quick note, just like Nils, a disclaimer about any information that's provided here. You please make sure do your own due diligence before making any decisions. Luxfer Technologies, we are part of a wider Luxfer group. We're registered on the New York Stock Exchange, and we're a group of companies that develop technologies for, as it says, they're making a safer, cleaner, and energy efficient world. Some numbers for us is that in 2023, the group did just under 400 million of sales. And you'll see on the right-hand side, there's two pie charts that show you a little bit of a distribution of where our markets are. Particularly of interest today is the upper pie chart showing that defense and transportation make up a significant part of the wider Luxfer Group's markets, and they play a significant role for Luxfer Technologies as well. So broadly, Luxfer Technologies, we are a division of the Luxfer Group, and then we have two main sectors, magnesium and zirconium. So our zirconium section, as you can see on the right-hand side there, provides catalysts, for automotive as well as industrial and consumer electronics, etc., all based around zirconium rare earth materials. And then in our magnesium sector, we produce both magnesium alloys, which I'll be focusing on today, and magnesium powders. The powders are predominantly used in military flares in the defense sector, as you can see from the image on the screen there, primarily for countermeasures for aircraft protection, as well as there are some other industrial applications for the powders. Magnesium alloys, we have applications predominantly in aerospace, but we also deal in luxury automotive, have some general engineering applications as well as applications in the oil and gas industry. So quite a diverse range of applications for us there. So today, getting into the detail of what I'm here for today and to talk about the aerospace and defense applications. Just quickly for anybody that's joining that isn't familiar with magnesium, the first question is why do we even want to use it in aerospace? Well, the simple answer is its weight. The magnesium is 2/3 the weight of aluminium and significantly lighter than titanium and steel. So therefore, there is a real drive to enable the use of it in anything that can benefit from lightweight. It is easily formed through casting, and then you can easily machine it, possibly dry. We do that here in Manchester, and then that means we can recycle it very easily. Machining magnesium uses less power and can be done quicker as well. It can be welded, and then Martin alluded to comments about corrosion causing issues in the 1970s. Well, there's a new suite of alloys that have been around for several years now, but are gaining more and more popularity, and they are addressing the corrosion issues and also high temperature performance. And I'll go into a little bit about that later. And then finally, it is an abundant element, and so it's easily sourced, even though it may be that at the moment, the majority of it is processed through China. It is actually able to be found in almost all parts of the world. So I've explained why we want to use magnesium. Where is it used? And aerospace is a very popular area for magnesium. Now, I should clarify, based on what Nils had to say, I'm only talking about the magnesium alloys specifically. I'm not talking about magnesium being part of another alloy. So basically, aerospace is very keen on magnesium. It has been, magnesium has played a key role, or magnesium alloys have played a key role in aerospace applications for over 70 years. As Martin suggested or just commented, Luxfer Technologies are celebrating our 90th anniversary this year. And the real reason that magnesium has had such traction is, again, its lightweight properties and also its high strength to weight ratio. And this has meant that it has found uses in the likes of engine covers, transmission housings, electronic housings, flight control systems, and also things such as aircraft wheels. This has been very popular within fixed wing aircraft, such as the fighter jet, for example, shown on the right-hand side, and also with rotorcraft, such as you can see an image there of helicopters. So pretty much almost all military helicopters will have some magnesium alloys on them in some form. As they use the lightweight benefits of it. If we then look beyond just the aerospace to other defense applications, so in addition, you've got land-based applications whereby soldiers, they are being required to carry more and more equipment, and also if they are out carrying this equipment for extended periods of time, every gram can count. So you can see images there of typical applications that are now exploiting the use of magnesium. And they're again using the lightweight side of it. The durability of it compared to some alternative materials does provide that benefit for the man-portable devices. But we're also seeing a benefit of the thermal conductivity or thermal product properties of magnesium. And so it is being used in electronic devices, power systems, and batteries for the housings that those are contained in. Now, there was a question on the chat asking about, are these gearboxes and devices made from sand castings, investment castings, or all of the above? So the simple answer is yes and more. And I'll go into a little bit more detail about that later, but basically, yes, a lot of aerospace castings, and I think our presenter in a moment will go into some more details. A lot of aerospace castings, the majority of aerospace castings are cast as sand castings. There is a small amount of investment casting in the supply chain. I see that there's an opportunity there to grow that area. And then there is also the option to machine them from solid, and I'll talk a little bit about that later. One area that we can use is extrusions to machine materials from, and that is where, again, applications to do with in defense, where you have military sites, where you're exploiting the lightweight nature again of the material and the durability, and then also auxiliary components associated with aircraft, namely pilot helmets. They're undergoing a lot of forces when they're flying, and anything you can do to reduce the weight of the helmet and therefore the forces that are going onto the pilot's head is very much welcome. So in this example, just connectors between the helmet and visors, etc., are produced as from magnesium alloys. So I mentioned and was addressing the question with regard to how these made. Well, there's essentially three routes. And here in Luxfer Technologies in Manchester, we produce the material. We melt down the pure raw materials and alloy up the material. And we produce either casting ingot that can go to various customers, and they can then sand cast or investment cast a final product, as shown in the example on the images there. We also produce what is termed direct chill cast slab and billet. And these are large solid pieces of magnesium alloys that then can be machined into required components. Or we can take those materials, we can take the slab and we can roll it, and then that will produce a plate or a rolled sheet, which can have different or enhanced properties and be used in various applications. Or we can take the billet and that can be forged or extruded. And then we can take those materials and machine them into the final components. So if we consider the sandcasting process, the traditional aerospace alloys include alloys such as RZ5 or ZE41, WE43, and QE22. And the standard aluminium alloys are A356 and C355. We now have an alloy called Electron 21, which is addressing high temperature performance. So what you'll see from these graphs is that the A356 and C355, whilst they are comparable at room temperatures, once we start to get up into the range of 150 to 200 degrees Celsius, the properties drop off. So if I actually move on to a simpler version of this graph, you'll see that once we're above 150 to 200 degrees Celsius, we now have a magnesium alloy that outperforms the standard aluminium sandcast alloy that we see in a lot of aerospace components. And that is really where the sweet spot is for the applications at about 150 to 200 degrees Celsius. And there's a similar, not as distinct, but a similar situation with the tensile properties as well for the alloy. Martin alluded to concerns with regard to corrosion, and we have had that for alloys, the original alloys of the magnesium aluminium alloys, and then even a ZE41, which is a zinc rare earth magnesium or magnesium zinc rare earth alloy, and concerns over the corrosion. But actually we've seen in recent years with WE43 and Electron 21 corrosion performances that are approaching those of the aluminium alloys. And you'll see there in the image on the left-hand side, you can see pitting after 10 days in a salt fog test, pitting in the RZ5 ZE41 material, and no such impact on the Electron 21 material. So yeah, especially with the correct coating systems, end users are actually seeing really significant step change in performance. So they're seeing a much better life cycle cost and life cycle performance on their alloy, on their components, and therefore they're looking to choose some of these more recently developed alloys. The other thing that's assisting designers is certification that has gone through. So Luxfer Technologies have AS9100, but more importantly, Electron 21 for sandcasting, the ingot for sandcasting, established an AMS specification in 2004, and it was the first alloy to have full AMB data, which is a key part that is required for designers when they're looking at considering what material choices they're making. We followed this up in 2019, achieving an AMS specification for the direct chill billet and slab. And in between there, we also established Electron 43, an extrusion alloy, which also has its own AMS specification and has an entry in the MMPDS. So with those, that's enabling the end users, such as some of the names that was listed by Nils earlier, to consider magnesium, because that's the biggest challenge that we've seen for years, is that people don't know what they can do and what options there are. If I now look to the direct chill billet and slab very quickly, we have introduced this as a complementary product to the sandcasting route. There's some images there of the slabs that are cast here in Manchester, And these just provide the end users with the confidence that they can start purchasing material in the same way as they're buying competing alloys, that they can buy a certified block of magnesium, machine it out with the confidence that that component will be a successful component and will pass all the testing requirements. We went through rigorous testing to validate that this material would match or exceed the properties of the sandcasting element, sandcasting alloy. And so we can provide that with confidence to the customers, and that gives them an extra suite and extra options. It gives them confidence in the quality and also in the lead time that we can deliver these materials to them. And we have one customer which we converted from a sandcasting to this due to an urgency with a component. And to this day, we've provided over 1,500 parts to them without them returning a piece to us. I'll now move on to discussing the extrusion route, which is another alternative option. It provides slightly higher properties with, you can see there, ranging good properties up to 250 degrees Celsius. And this provides the option for people to specify in higher temperature areas or where they're needing higher strength requirements. You can also see that there are, you have the opportunity now to extrude near-net shapes and some detailed profiles if required. Magnesium is harder to extrude than some other alloys such as aluminium. It takes a longer process, but it is possible to achieve and extrude components. And then from there, we take those and we'll machine them into the final finished shapes that the customers require. Which that then leads me to the final thing I wanted to talk about. And that is really what is stopping magnesium being used more widely in aerospace and defense. And we believe that a large part of that is down to the supply chain. And we are spending a lot of time speaking with end users. They're very keen and very interested to use the alloys. However, they do not know how they can use the alloys. Their supply chain is not geared up to use magnesium. So we've been doing a lot of educating of end users and the supply chain on how they can use the magnesium and how they can handle it. But one of the other things is that we actually are looking at how we can nurse and assist people through that whole process and provide those finished parts. So each step is talking about the working with the end users, how they can understand the alloy, because quite simply there isn't the knowledge within a lot of end users. So we as an industry need to educate those, and webinars like this are wonderful for that. And then we can take through the alloy manufacture, and we go through the steps of machining, applying surface protection, and then finally delivering the final part. On the topic of machining, machining magnesium can be carried out dry. That's certainly what we do here at Luxfer Technologies. We can then recycle the material very easily. It is possible to recycle magnesium that has been machined with a lubricant, but is much more difficult. But the key thing with machining magnesium is that it can be quicker and use less energy than alternatives. And there's some figures at the bottom of this slide showing you the difference in the speeds of being able to machine magnesium compared to popular aluminium grades. And there's just further summary of that. It can be much quicker. And the only thing is, as it says there, you can machine it dry. You just need to keep your housekeeping. So that's keeping clear of the area, clear of waste, swarf, etc. So just quickly, magnesium, it's been around for a long time. It's not particularly new in aerospace. There is many applications that are exploiting it. I will take the opportunity. There was the question about drones. It really depends on size. So Martin commented that he was at a drone event where he didn't see much. People didn't know much of it. I don't know, but certainly when we've spoken to people, small drones, generally you're struggling to see where the benefits are. But drones can range from one that can be carried in your hand through to one that is basically the size of a small aircraft. And as you get up to those sort of sizes, there's absolutely applications for magnesium in there. Depending on what is driving the drone, if you're talking about batteries, you're talking about additional, if it's an electrified drone, then you're talking about additional weight, where magnesium alloys are being used to reduce the weight to compensate for that. If you go through to the very large drones, these are being driven with the same engines as you would see in a standard typical fixed wing aircraft. And so those have exactly the applications and absolutely the same requirements for magnesium alloys. So yes, there's opportunities there with drones. It's usually the larger drones and also the drones that some applications, should the drone want to be up flying for longer hours, every kilo of weight saving can mean extending the range and time that can be in the air. So there are lots and lots of opportunities for us for people to exploit the benefits and the lightweight properties of magnesium alloys. I've talked a little bit about the newer alloys that are providing some more options, and then and the corrosion resistance. Really, we do need to look at that enabling of the supply chain and working to make sure that when people want to use magnesium, they know how to get it. And then, yeah, I've just commented on the drones as well. And with that, I'll open up to see if there's any questions on the chat or any comments from Martin.
Thank you, Ross. Very interesting, and I'm glad that you saw more magnesium and drones than I saw. Probably I saw the wrong drones or the small ones. But however, we saw very small drones out of Dixon molding magnesium as well in the past. So it's out there, and it's as you said, as they are reaching the size of a small aircraft, it's the similar lightweight issue which counts, and then magnesium has certainly an advantage in that. If I look at we have time, so you could, Ross, you could look into the questions. Some questions are directly related to the operation of Luxfer.
Oh, okay, yes.
So one question was
okay, yes.
from
Sorry, I was just scrolling down.
Yeah.
So there's a question here: how do I see magnesium alloys being utilized in EV air mobility? Absolutely. You've got really, it comes down to the lightweight. Is the benefit there. Generally speaking, you're not talking about too much with temperature, to my knowledge. So you're really more looking at the lightweight nature, the corrosion resistance, and the mechanical properties that you need to achieve for that. But absolutely, magnesium can play a role in eVTOLs. And there is interest definitely around the world for that. Another question: how does the sandcasting process manage oxide formation? So this, I really would say, if you would like to know a lot more, you'll need to speak to our next speaker or one of our specialists in the team that we have here at Luxfer Technologies. Something I didn't delve into is one of the things we do is we partner a lot with foundries to help them manage all the process to do with melting and casting. Yes, there is cover gas. You can use flux as well to protect, and there's a lot of skill that's required to make sure that we produce a clean melt, and then when we actually cast the material, we don't introduce further oxides into the process. And yeah, our next speaker is an expert in making sure that those things don't get into the castings.
Maybe Ross want to add. I think it's a very interesting thing about the EV aircrafts, that they in the opposite of fueled aircrafts, that they're losing weight when they fly.
Yeah.
The EV aircrafts, as it's its battery or hydrogen, it keeps the weight the whole
Yes,
flight. That is an interesting aspect, and magnesium probably is even
yes,
more interested for lightweight than as well. I would say
yes.
all the other questions about Dixon molding and alloys, we gonna leave out of this webinar because
Yep.
it's not directly related to that. Because you are doing Electron 21, maybe you can uh, answer Dave's question about the recyclability or sustainability impact of recycling rare earth alloys.
Yes, so we recycle all our alloys here on site. We can recycle rare earth containing alloys. One of the key things that we do is we look to work with our supply chain to recover any of the waste that they produce or the scrap that they produce, and we will recycle that. There are some limitations there. Of course, there is material that is lost, but we're working and continue to develop processes to minimize that because, of course, rare earth containing alloys are very valuable and we don't want to waste them. So it is definitely things that we are working on, and well, we do already. There was two other questions that I saw here. One question was, oh yeah, just very quickly, we do not produce primary magnesium at Luxfer Technologies. We alloy magnesium and alloy metals. 3D printing applications. We have done a small amount here at Luxfer. We think there is still quite a lot to be developed with regard to 3D printing of magnesium. However, we absolutely use 3D printing capabilities for sand mold production with our customers. Absolutely, yes.
Yeah, probably I see a question from UK, from Germany, is about recycling in general. So of
Yep.
course, recycling is very interesting for the magnesium industry. It's done since many years as process recycling, and we do also get requests from OEMs to have defined alloys with more recycled content, similar to the aluminum industry. So this is certainly an ongoing
Yep.
topic. And in the IMA, we have a special design working group on sustainability for recycling. So there is the best place to discuss those questions.
Okay.
There's a question about, you said about corrosion. Maybe you say a few words about flammability, not that
Oh yeah.
unimportant in aerospace.
Absolutely. So that's the other myth, if you like, that we have spent many years to try and bust, as the show says, and that is that magnesium is flammable and will burn. So first of all, magnesium castings would be very difficult to ignite instantly. All aerospace engines have to go through various rigorous flammability tests. But in addition to that, Electron 21 and Electron 43 are both from a suite of alloys that we've developed at Luxfer Technologies that have flammability resistance in them. So there is a fire test whereby a bar of magnesium is put in front of a flame, and that bar will melt. And if the magnesium catches fire, then that is not acceptable for by the FAA. Whereas Electron 21 and Electron 43 both have shown properties where they actually melted, but they self-extinguish. I won't go into the detail of it. There is some information on the internet about it. But yes, the perception within the commercial aviation industry was there was a concern about flammability. We have addressed that in 2008. We actually had the FAA have approved both Electron 43 and Electron 21 to be considered for applications within the cabin on commercial aircraft because of these properties. Now, that doesn't mean that they're free to be used anywhere without any guidance, but they can be considered now, and no other magnesium alloy can be considered for inside the cabin at the moment.
Yeah, thank you, Ross. And with this, I think I want to come to our third speaker, Mr. Navin Kumar from Hindustan Aeronautics from India. Very welcome to this platform. As you may know, IMA is a partner company of GDC Tech Forum, a very good and large network in India. And we are very happy with this cooperation. And we had our first event in January. We do the next one in Pune in India in December. And without this network, certainly we wouldn't have this speaker today. So we're very honored to welcome Navin Kumar to our webinar. Navin has education at the National Institute of Foundry and Forge Technology from Ranchi, and he has over 10 years of experience in magnesium sand casting and process design in magnesium foundry operations. So please go ahead.
Thank you, Mr. Martin. Hello.
Yeah, we can hear you. You can share your presentation. Is it okay? Please use the share function at the mid bottom of the screen. And then, yes, it's coming up.
Navin, we can see your screen share, but just not the slides.
Yeah.
Yeah. Is it visible?
Yeah, now you select this and then it must be okay.
Yeah. Is it visible now?
Yes, yeah, now it's visible. If you just go it on full screen mode and then we all set.
And if you're able to speak a little bit louder into the microphone, your audio is kind of low.
Hello, everyone. I'm Navin Kumar from Foundry Port Division of HL Hindustan Aeronautics Limited. And today I'll be talking about scope of magnesium casting in aerospace sector in India. So let's start. Magnesium is seen as a key material in aerospace manufacturing because of its ability to reduce weight while maintaining its strength. In aerospace, every gram counts. Lighter components means better fuel efficiency, improved payload, and extended aircraft life. India's aerospace and defense manufacturing sector is expanding rapidly with ambitious projects like light combat aircraft, ALH, and various other defense applications. There is a growing interest in materials like magnesium to meet the future demand. So, why magnesium alloys? Most of the it's because of all these most of the points. I will just try to brush up that. First, they offer very high strength to weight ratio. You can see from this comparison, this high strength to weight ratio makes them ideal for structural applications where weight reduction is critical. Secondly, they are easy to machine compared to many other aerospace alloys which simplifies the manufacturing of complex parts. Third, magnesium alloys have good thermal conductivity, which helps in heat dissipation from critical components like engine housings or gearboxes. And lastly, magnesium is recyclable, which supports sustainability and reduces material costs over the long term. Now, the global leading aerospace companies like Airbus have already integrated magnesium castings into their designs. For example, Boeing uses magnesium for gearbox housings in some aircraft, which, because it reduces weight without sacrificing the strength of performance. Similarly, structural housing and mounting brackets made of magnesium are widely found in helicopters, drones, and even missile systems. Coming to the current status in Indian aerospace sector. In India, efforts are already underway. Founded for division of ACL and Defense Research Development Organization (DRDO) are developing magnesium components. Some of the indigenous platforms like combat aircraft, ALH, already included magnesium parts as I mentioned earlier. However, the supply chain remains a challenge. The number of qualified suppliers is limited in India, and scaling production is still an ongoing process. We need to strengthen the entire ecosystem in India. So basically, the casting technologies which are used in India these are the three, and the last one is emerging technologies, which is still in the experimental stage. So high pressure die casting is widely used for high volume production because it provides good surface finish, repeatability, and is ideal for parts like housing and brackets. The gravity casting works well for moderate complexity structural parts, offering good mechanical properties with less risk of porosity. But the sand casting remains important for large or complex shapes that are difficult to produce. It's slower but flexible. Most importantly, modern alloys like RZ5 can be cast only through sand casting route. Recent development in additive manufacturing with magnesium alloys, which is still in the experimental stage. Now, despite of these advantages, magnesium does present some challenges. So let's talk about some of the points. First is corrosion. Corrosion is a key concern, especially in high humidity conditions and outdoor applications. Second, as I mentioned, India has a limited number of suppliers qualified to manufacture the magnesium alloy castings. Third, magnesium is more expensive than aluminum. Even though the pure magnesium aluminum rates are not very much different, but ultimately when we make alloy with rare earth and zirconium based hardeners, the cost of magnesium is far more than the aluminum alloys. And finally, the fire risk. Fire risk requires strict safety as magnesium is highly inflammable in molten and powder form. These issues slow down the adoption, and they are not impossible to tackle. So how do we tackle these hurdles? Recently, advanced surface coatings and chemical treatment help reduce corrosion risk significantly. Utilization of magnesium alloy is key. Developing our own alloy grade suitable to local conditions of India and industrial capability will reduce dependence on imports, and it will increase the adoption among the local players in India. There is a need to heavily focus on skill development, training engineers and technicians in magnesium-specific processes critical for wider adoption. There are only few handful of engineers and technicians in India who are capable of understanding the technical part of magnesium alloys, especially for sand casting. Finally, global collaborations, especially with organizations like IMA, will help their best practices, bringing expertise and build a stronger ecosystem. So, how is the future outlook in India? The government supports policies like Make in India and Atmanirbhar Bharat and support domestic manufacturing of strategic components. New opportunities are also emerging, especially in drones, satellites, and defense vehicles, where lightweight components is key. Additionally, there is a growing potential for exporting magnesium casting from India to global aerospace players, as and when our supply chain matures. So, finally, I would like to conclude with magnesium castings are strategically important for India's aerospace and defense. The industries need to continue investing in research and development, strengthening the supply chain, building industrial partnerships. This is not just about reducing weight, it's about building a competitive, self-reliant ecosystem. I encourage all the stakeholders, industry, academia, and the government to work together in driving adoption of magnesium castings in aerospace. Thank you for your time today. I would like to reach out more people. Here are my contact details. Thank you once again.
Thank you, Navin. Very interesting presentation. We were all listening very carefully. Your audio was not the best, but it was understandable. Yeah, I don't see any question. Do you have any questions for Navin? And please type in the Q&A. We have some time left.
I would like to add one point. Hello, am I audible?
Yes, go ahead.
Yeah. So I would like to add. In India, HCL is the only player who is making castings using modern alloy like RZ5. With increasing requirements for aircraft, future aircraft, next version aircraft, we have a huge requirement for magnesium alloy casings and housings. But we have the rejection of castings due to metallurgical reasons is enormous. So that makes us difficult to invest more or to look more for the magnesium. There, I would request IMA to bring all the technical experts so that we can share our knowledge and encourage us to use more magnesium. Because ultimately, when the rejection rate is more, the designers would prefer to go for aluminium thin wall aluminium castings. So the adoption will ultimately go down instead of going the trend to increase.
Yeah, thank you for your input here, and I can only underline that. As I said, we have the cooperation as a partner organization to GDC Tech Forum and joining their mega event in beginning of December with a 2 days dedicated magnesium conference as well. And if you are interested to join us there and to meet representatives from the Indian market, both for automotive and for aerospace, it is certainly a very lively forum to be there. IMA is also offering tour for international participants to visit a few IMA members who has built up die casting capacities, also sand casting capacities in India. So if you are interested, contact me or Navin. I think he would be also happy to direct you to our events. Why we have combined aerospace and defense, I think it's obvious that also in the policy area, people talk about the dual use concept. So what is developed and approved in the military could also be approved and getting an application in the commercial aircrafts as well. So I think with this, I don't see any more questions. Here, just have a look. No. Oh, my slides are not going further. Okay, my slides are not going any further. So what I wanted to show to you is our invitation for marking your calendar, your diary already for the Magnesium Conference, Global Magnesium Conference next year in May in Montreal. And yeah, with this, very happy that you all spend your time here with us, with the hopefully interested and valuable webinar for us. Thanks again for all the speakers. You will receive a link when the presentations and the recordings will be ready. There also will be the email addresses of the speakers. So if you have a direct question, please reach out to them. And I hope we have also interested non-IMA members in our network. And if you have any questions about joining our network, please reach out to me or to Rose Eaton or to the info mail of the International Magnesium Association. And we are very happy to take your request further. So with this, I would like to thanks everybody again for this, and hopefully hear and see you before our Montreal conference, but at latest there. Also, okay, thank you. Bye-bye.
Thank you, everyone.